Hi everyone, these are the section 2.4 notes, and these are going to be over adding polynomials or really just looking at adding like terms. So we're going to start with the explore activity. We have some different additions that we're going to look at what we can actually add. So if we look at the first one, we have 2 centimeters plus 7 meters plus 6 centimeters. If we think about that, the only things that are really like or similar in these are the centimeters. So really what we can think of it as is 7 meters plus 8 centimeters. But we can't just easily add these together without us doing some conversion. So the easiest way to look at this is just write 7 meters plus 8 centimeters. When we look at the next one, it says 5 quarters plus 8 dimes plus 20 quarters. So the quarters we can add together, so we can have 25 quarters, and then we would include the dimes separately, so plus 8 dimes. And looking at the last one, it has 5 hours, 2 minutes, plus 7 hours, 58 minutes. So we would be able to add the hours together with that to get 12 hours, and also then include the minutes. So 2 and 54 would give us 56 minutes. So we can see from the explore problem that we are able to add only like objects. If objects are unlike, we can either find something common about them and combine further, or leave the objects as they are. For example, if we have 5 quarters plus 6 dimes, we do not have 5 quarter dimes. Keep this example in mind when we move to more abstract cases with actual variables or letters. So before we look at adding objects, we need to understand the notation used to indicate objects that are being added and the number of them. There are several ways to indicate multiplication of two numbers. So when two numbers are being multiplied, we might use an X symbol, although when we usually look at actual problems, an X symbol isn't usually used because it can be mistaken for the actual variable in that operation. And so we typically would use a dot, or we would use parentheses either around both numbers or around the second number. Likewise, there are several ways to indicate multiplication of a number and a variable. With this one, you would not see the X at all, because then that would be extremely confusing because we'd be looking at variables as well. So we could see it just no sign in between, so that's just invisible multiplication there. We could see it with parentheses around both, parentheses around the second, or parentheses around the first, or you can see it with a dot just like the previous one. The most common way that you will see it is that first example. The factors in a product indicate the number of objects being counted and the type of the object. So if we express 2 parentheses 8 or 2 times 8, it means 2 times 8 or 2 eighths. If we look at 2 over 8, it can mean 2 times 1/8 or 2 eighths. Likewise, if we have 2n, that means 2 n's. In an algebraic expression, the coefficient tells us how many of the objects there are. Remember that the coefficient is the number in front. So if we were to look at 2n, the coefficient would be 2. The variable factor that follows is the object being recorded. If the same type of objects are being added, also known as like terms, they can be combined further to make a simpler expression. Like terms have the same variable raised to the same exponent. They do not need to have the same coefficient or leading number. For example, 3xy and 4xy are like terms because they have the same variables and they're raised to the same exponent. In this case, the invisible exponent would be 1 for both x and y. But if we look at this one, even though the coefficients are the same, the variables are raised to different exponents. The x is raised to a 1 here, where it's raised to a 3 here. And likewise with the y's, those don't match either. Often an expression will be given with a brief direction, simplify. This one word can have many meanings depending on the context. In general, to simplify is to perform the given operations to shorten or condense the expression. So to simplify or combine like terms, the coefficients are added, but the object does not change. This is true in numeric expressions like 2 meters plus 7 meters, which is 9 meters, and it can also be true in algebraic ones. So if we look at this example, it says to simplify the expression, we combine like terms. Notice that there are 4 terms, 2 that have x as the variable, in the pink right here, and 2 that have y as a variable factor. We can use the color or symbols such as the boxes and circles to make the like terms more noticeable. Keep in mind that the term with its sign, keep the term with its sign. So 7x and negative 3x are like terms, and 2y and negative 4y are like terms. So if we want, we can even just think of reordering them and then combining the coefficients to simplify the expression. So to simplify an expression, we're going to find like terms. And then we are going to add or combine those coefficients. So if we look at this one, the like terms here, this has an x and a y, so we want to look for any other terms that have an x and a y. That would be this term. If we combine those, negative 5xy plus 10xy will give us a positive 5xy. The other 2 terms, there's no other term with a y squared, and there's no other term that's just a number. So those would just be included after that. So we would end up with 5xy plus 7y squared plus 2. I will not be picky about which order you rewrite it. So if you wrote it as 7y squared plus 5xy plus 2, that would be correct as well. Since adding like terms depends on using the coefficient, it's important to be able to recognize the coefficient even when it is not written. So when no coefficient is written, it is assumed to be 1. For example, x is the same as 1x. And if we have negative x, that's the same as negative 1x. Okay, so in each problem, we'll identify the like terms and then simplify the expression by combining like terms. So in number 1, we have 2 terms that are just a. So these would be our like terms. Remember that if we don't see a coefficient in front of the letter, it's invisibly just 1. So if we combine 1a and negative 9a, we get negative 8a, and then we would just add 23 after. For the next one, we have an x squared term, and we have another x squared term. We also have terms with y's. This term with just the x, we don't have another like term with that, so that would just be added on after. So if we combine the x squared terms, we have 8 plus 16, which gives us 24. You want to make sure that you do not change this actual base. So the base will not change. So the object here is still going to be x squared. Then we want to add the y terms. So we have 4y plus 8y. So that would give us 12y. And then we're just going to include the minus 12x after. Okay, for these ones, these technically are raised to the same power because we could write these as 3x to the 1/2 plus 5x to the 1/2. So if we look at that, it's just raised to the same exponent, but you can even just look at it as this is the object after the 3, this is the object after the 5. So if we combine those, 3 and 5 would be 8, and you will not change what comes after. So it's 8 square root x. For number 4, we want to combine any like terms with our xy. So I see another xy right here. So if I combine those, I get 26xy. And then I also have like terms with just x's. So negative 9x plus 8x will give us negative 1x. And if you want to, you can write it like that, or you can write it as 26xy minus x. Either one is correct. For the last one, you can ignore the parentheses here since we're just adding. So we're going to combine any terms that are just numbers. So those are just constants or numbers. So we have 3 plus negative 7. So that would give us negative 4. And then we have 4i and minus 9i. So if we combine those together, we get minus 5i. In section 2.3, you learned about exponent rules for multiplying and dividing. This section explores the ideas of addition and subtraction, some of which have exponents. So we're going to kind of look at some problems and make sure that we don't get them confused together. So if we look at the ones that are adding or subtracting, so that would be 8 and 10, those still use the rules that we learned today. So I want to make sure that they are like terms. So I want the same variable raised to the same exponent. So we have that. So I can just combine how many there are. There's 4 and another 4. So that will give us 8x to the third. For number 10, we have x's in both of them, but they're not raised to the same exponent. So if we ever have a case like this where there's no like terms, we would just give our answer as a repeat of the actual question. It's already as simplified as it can be. Okay, reviewing what we looked at in our previous section in 2.3 where we multiplied, we would multiply the coefficients or the numbers in front, so that would give us 16. And then if we're multiplying, we're going to add the exponents. So that's going to be 3 plus 3. So we get 16x to the 6th. For this one, same idea. Multiply the coefficient, so we get 16. And if we add the exponents, this has an invisible exponent of 1. So we get 3 plus 1. So we get 16x to the 4th. We saw in section 2.3 that using units while simplifying geometric expressions can make it easier. Some geometric formulas also require combining like terms. So we're going to go ahead and just do part A. We're not going to look at part B. This says find the amount of edging needed for a rectangular deck that is 76 centimeters by 46 centimeters. So if we look at a rectangular deck and we look at the edging needed, if it's 76 centimeters by 46 centimeters, remember that we also want to include all of the sides if we're looking at edging because we want to find the perimeter. So this side would also be 46 centimeters. And this side would also be 76 centimeters because the opposites are going to be equal. So to find the perimeter, we're going to add up all the sides. All of these are like terms because they're all just in centimeters. So we'll go ahead and just combine all of the coefficients. So we get 244 and it just remains centimeters. With perimeter, our units are just going to be units. They're not going to be to any exponent or to any power. Okay, this sums up section 2.4. If you guys have any questions, please let me know.